Going for more examples for our linear graph, we have two questions here, or let me say there are two examples here to give, guys. I'm having the first one, which is saying determine the equation of a straight line passing through -1 and 1 and parallel to y minus 2x is equals to 4. And then the second one is saying determine the equation of a straight line passing through 2 and -3 and perpendicular to 2y plus 1 is equals to 3. Now, there are only two things to talk about for perpendicular and parallel. When we say that lines are parallel, it means that the first thing that should always come to your mind is that the gradient of those lines, they are equal to one another. Meaning if I can have a line like this parallel to this one, the gradient of this line parallel to that one is the same, meaning my m1 and m2 is the same. And now for perpendicular, the gradient, note that every time when they say the gradient of something is perpendicular to something, it means that their products are giving us -1. That would be the gradient of this line perpendicular to the gradient of this line. When we do the product of them, they must give us -1. That is what we are going to use to do the two examples there. Now remember, note that this is a straight line graph, meaning it's a straight line. If it's a straight line, you should determine the straight line graph which is parallel to it, which is a new one, of course. For yourself to determine that, you should always try to make y subject of the formula there so that you can identify your gradient from the graph. The purpose for us determining the gradient from that line is because we do not have two given points, but we only have maybe let's say this is point A. We only have point A there. Therefore, if you were to determine the equation of that straight line, you have y minus 2x is equals to 4, and we are trying to find the equation of a new graph, but from this name, because we are already told that our the first line is parallel to the other line. It means I'm going to look for the line which is parallel to this one, and we are saying the gradient of parallel lines is the same. From this, I'm going to solve for y, making y subject of the formula so that I can take out my gradient from my graph. So it means I'm going to have y is equals to, I take this 2 that side, 2x plus 4, and then from here I'm saying my gradient is the coefficient of x. It's always here at x, at a variable x, meaning my m for 2, which is the same as m for 1, is going to be positive 2. Now note that if it was -2 here, we was going to take it as -2, and we do not take -2x or positive 2x, but we only take the value of the gradient, of course. Now, if I was to determine my gradient, I'm going to have y is equals to mx plus c. Remember, I already found m from the from the old equation, of course, and then now I'm trying to determine the equation of a new one, but with those points that are points for a, of course. It means I'm going to substitute my y for that a here, which is going to be positive 1 is equals to, now my gradient is 2, I have 2, and then for x value is just going to be -1 plus c. Remember, we are determining the value of c now, which is a constant. I'm having 2 multiplied by this is going to be 1 is equals to -2 plus c, and then I take the 2 that side, which is going to end up giving me 1 plus 2, and then my c is going to be c is equals to positive 3, and then now the equation of a new line is going to be y is equals to my m, which is 2x plus my c, which is 3. Now going to the next example, we have the equation saying determine the equation of a straight line passing through this point and perpendicular to that line. Now we're saying that the gradient of perpendicular lines, when you multiply them, they must give you a product of -1. It means from that we can determine the gradient. Remember, we are saying the gradient is at a value, or it is at a variable x. And sorry guys, here I did a bit of a mistake. I left my x here. This is supposed to be 1x. Now we are saying we are going to make that things we are going to try to make y subject of the formula. Now making y subject of the formula means I have 2y plus 2y plus x is equals to positive 3, and then making y subject of the formula, I'm going to have y 2y is equals to, I take y that side, I mean x that side, it will be negative x plus 3, and then but I want to make y subject to the formula, I divide both sides by 2. I will have 2 here, I will also have 2 here. Now after dividing both sides by 2, my 2 will cancel 2 and I'm left with y, and then my y is going to be negative x over 2 plus 3 over 2. And then from here is then that I can take out my gradient. My gradient, remember we are saying it is where we have a variable of x. It means my gradient is going to be y is equals to negative 1 over 2. And then from having my gradient is then that I can determine the equation of the new line, of course using those 2 points there. I'm going to have y is equals to mx plus c, where my y is negative 3. But now from having determined my gradient of the old one, I know that the gradient of the old one multiplied by the gradient of the new one is going to give me negative 1. So I'm going to have m of old multiplied by m of new is equals to negative 1. And then my gradient of old is simply negative 1 over 2 here, multiplied by my m of new. And then now we are using multiplication sign. I mean, we are having multiplication sign that is just combining the 2 for m new, which is going to be multiplied by negative 1 over 2. It means we must divide both sides by half, or somebody can simply say, no, I want to multiply everything here with 2 so that I can eliminate this denominator. Multiplying everything here with 2, I'm going to have 2 that and multiplied by 2 that side. I'm going to have negative 1 m of new is going to be equals to negative 2. And then from here, I am looking for m new, but I'm not looking for negative 1 m new. I divide both sides by negative 1. I'm just going to have my m new as positive 2. Goes to positive 2. Now from here is then that we can determine our equation. We have y is equals to mx plus c, and then we're simply going to substitute the value, the point for y and x as well to get my c. I'm going to have negative 3 is equals to my m is 2. I have 2 into my x is 2 there plus c, and then I'm multiplying this with this. I'm going to have negative 3 is equals to positive 4 plus c, and then I'm taking my 4 that side. I will have c is equals to negative 3 minus 4, which will end up giving me negative 7. From here is then that you can write the equation of a new line, which is going to be y is equals to, my gradient there is 2x, but my c here is minus 7.